My next guest is a brilliant scientist, mathematician, and cosmologist. Interestingly, he also happens to be a practicing Quaker. Can these two worlds exist simultaneously in one person? I asked him about it. His answer is fascinating, and he has a lot of other interesting things to say. Come check it out next on Beyond Belief. Welcome, Dr. Ellis. It's really such a pleasure to be able to meet you and to have you on the show. And I wanted to open up with a sort of a general question, which is, you have had a long and distinguished career at this point in mathematics and cosmology. And if you wanted to summarize everything that you've learned, I know that wouldn't be possible. It would take many books to do that. But is there one idea that you could distill down? What through your research would you ultimately like to share with the world, if there's one or two things?
In my academic life?
Yes.
I think the thing which is most important is that in trying to understand the world, it's nice to have simple models, but the real world is very complex. And one should try to understand as much as one can of it. There is so much fascinating stuff to learn about. So I'm a physicist. I started off, I got really deeply into cosmology, general relativity, but I've spent the past 15 years of my life learning about the brain, microbiology, stuff like that. And there is so much to learn. It's incredibly fascinating and it's incredibly complex.
Yes, for sure. And for us lay people who don't have the same grip, on the subtleties and the nuances of the mathematical world or the cosmological world, would you suggest that the best that we can take from it is a certain kind of awe or a certain kind of respect? What would you think that a person who's a non-scientist can appreciate most about the scientific endeavor?
Well, there's really two separate questions there. About the scientific endeavor is it makes false starts, it goes in wrong directions, but it does succeed in going forward and establishing things which are very well established. A simple example is Newton's laws of motion. They're used to design motor cars, trains, aircraft, and all the rest. They're not the most accurate laws in the world, but within their domain of application, they work exceedingly well. Yeah.
Yes. And so I know that your work has focused at times on the distinction between, let's call it the big and the small, or the top down.
Yeah.
And let me quote something that you actually wrote in one of your books, which is, the digital computers that dominate in the world around us are based at the bottom level on a binary coding system. That is, every program and all the data it uses are nothing but a sequence of zeros and ones. A Bach sonata played on your digital system by Yo-Yo Ma will ultimately just be a sequence of digits. A Rembrandt self-portrait displayed on your screen or your holiday photos stored in your computer will be other such sequences. Okay. That's understood, that when you boil things down to their base component, those base components seem radically different than the big picture, let's call it, whether it's music, whether it's art, whether it's a human being.
Yeah.
And my question to you is, given that we see these radical changes in the nature of reality at different scales, obviously quantum physics is different than Newtonian physics, the big versus the small. Isn't this all counterintuitive? Isn't more grains of sand just a bigger pile of sand? Why should we expect that when you get enough of these things together, it creates something wholly new? That seems crazy to me.
Yeah, a great pile of sand is nothing but a pile of sand. But the whole of life is based in molecules, biomolecules, proteins, actually. And they are incredibly complicated. And the thing is, they have got to be what they are through the processes of natural selection over hundreds of millions of years. and they each have a function or a purpose. So, for instance, we have a rhodopsin in our eyes, which enables us to see. We have hemoglobin in our blood, which transports oxygen from our heart to our brain, and that enables us to live. And each of these molecules has got this fantastic structure, which has been elucidated relatively recently. It's got to be what it is because it carries out these functional purposes, and we can understand and determine those purposes. Now, the key thing which I've been fighting for the past 15 years is, if we go back to the computers, you've got your zeros and ones in the bottom. What determines what they are is the algorithm which is processing them. And the algorithm might be one which is associated with making pictures. It might be one for calculating interest rates or something like that. There's a top-down action from the logical structure of the algorithm to the way the bits flow backwards and forwards in the gates at the bottom. And this idea of downward causation is what removes the reductionist dream that everything is nothing but physics going on, that if you understood all the physics, you would be able to predict what's happened. You won't be able to predict what happens unless you know what is going on at the higher levels. And that's a crucial lesson, which I think everybody can understand. And and the further one, which of course relates to what you're interested in, algorithms at the top level have got values associated with them. And we're seeing that in social media at the moment. So algorithms live in a context, a societal context, where values determine what algorithms are written. Are they there to make money or to enable you to enjoy yourself by looking at photographs and so on? And those, are they there to enable Facebook to make a lot of money by enraging other people and getting them to So values are the topmost level, which float down all the way down to determine which electrons flow through which gates in the transistor, if it's, let's say, running Facebook.
Right. And therein lies the true fascination for me, is that hierarchical structure. And and for you as well, I know that, you've written extensively about this, and I want to ask you more specific questions about it in a moment, but I think that there is something significant on the top-down hierarchy and how it affects reality, and vice versa.
Yes.
But would you say, therefore, in conclusion, for right this second, that the concept that the whole truly is greater than the sum of its parts is true and real?
Yes, so that is true in many, many ways. And this thing it's so obvious once you're looking for it. You can't not see it all over the place, but it implies in every field. It applies in physics, in computer science, in biology, and in the way that the mind works. And let's take two examples. One example is homeostasis. Every human being has got macro systems which keep us in stable equilibrium. They keep our blood pressure constant, our temperature constant, and so on. And you are ill if those systems don't function. And then a simple example of a homeostatic system actually is a thermostat. And a thermostat, you dial it up and it turns a heater on, and molecules in the room flow faster. So that's top-down action from your mind to the dial to the flow of molecules in the room. And one of the biggest examples of top-down causation is evolution. So, as I said, your eyes have needed molecules which enable them to detect light. Rhodopsin was found by natural selection to do the job. And why was it developed? It's because it gave an advantage to animals who had sight over those who didn't have sight. And so that's the kind of chain. From the macro level thing, it's good for survival in a given environment. And incidentally, you do not need eyes if you live at the bottom of the ocean, which is a different context. But if you live on Earth, you need eyes in order to have a good advantage. And that, over evolutionary history, selected those particular molecules so that we could incorporate them in our eyes, and it also selected developmental systems that would produce those molecules in our bodies as we grew up.
So the information generation that's necessary to create something like the eye seems extremely complex, robust.
Yeah.
Yes, it almost seems, and I know that this is this starts to move into a more controversial area of science, and maybe it touches on the metaphysical, but it often almost seems as if the design is extremely good, probably from the beginning. We have this question of irreducible complexity that I've read about, that if you don't have all the features of the eye working simultaneously, you have nothing. How do we get, is Darwinian evolution sufficient to produce the information necessary for a complex structure of the eye, or is there some kind of top-down overall design in place, that gets a blueprint that gets sort of executed on?
Yeah, no, I believe Darwinian evolution in the modern understanding of that phrase, which is much more complicated than Darwin understood because he didn't know about genes. And I think it's quite sufficient. We do not know all the steps, but that's because it's a historical science and a lot of the relevant data has got swept away in the mists of time. But the fact it's difficult to explain it, the exact trajectory, does not mean there wasn't such a trajectory there. And so I'm certainly not going to go into the intelligent design thing. Just two comments about this. If intelligent design was true, if things were designed by, as it were, God poking his fingers in the natural order, the question is, why didn't he do a better job of it? Why didn't he make teeth better than they are, for one example? Or our eyes actually are a bit of a botch up because they have a blind spot, and the blind spot is quite amazing. The blind spot is as wide as 3 fingers when you hold your arm out, and you do not see the blind spot. You cannot see that there's a blind spot as you look at me. And that's because, given the botch up of that part of the eye, the brain has developed mechanisms to interpret the incoming information so that you don't actually see what is coming in. You see what your brain thinks you ought to be seeing. And that's
Right.
a very well-established way that the brain works. The brain takes the incoming data, it compares it with what it thinks you ought to see, and it tells you you're seeing what it thinks you ought to see, not what is actually coming in, because that coming in stuff is moving a substantial part of the picture, which is hitting your nervous system.
Yes, I know. I know that point has been made often about the eye, and it is a fascinating question. Although I could think of standing on one leg, we benefit a lot from having the concept of a blind spot as people. We relate to it on a social level, on a personal growth level. Like, the idea of having a blind spot is familiar to us and is useful. I'm not saying that that's the reason that an almighty creator specifically would have created the eye that way, but it's just food for thought that that there are certain benefits that come out of a misdesign, so to speak. Anyway, but
let me say something about metaphysics. I actually love metaphysics.
yeah, please.
I work as a scientist, I work as a philosopher, as it were, and I'm very clear when I'm doing which, and that's really important. The scientific part can be tested, the philosophical part cannot. So I want to point out to you, there's a wonderful book by Andreas Wagner called Arrival of the Fittest, not Survival, Arrival of the Fittest. And he talks about the space of all possible proteins. And that is an abstract space, a Platonic space. And this is something which has been the same since before life existed. It will be the same long after all life has passed out. And it delineates all possible proteins that can exist. And so nature, through Darwin's evolutionary processes, has to select the proteins from amongst those that can exist that are needed at any particular time for a particular function. So I believe quite strongly in various Platonic spaces, and if we could, if you want to look at various others of those Platonic spaces, I think that those are the deep structure of the cosmos.
I'm very interested in that, and I have a feeling some of the questions I have prepared will touch on that, because I want to ask you about causation, and so let's keep that in mind. But before we get there, I wonder if we could pivot back for one moment and talk about, you were president of something called the International Society for Science and Religion.
Yeah.
If I'm okay, and that is defined as a learned society established in 2001 for the purpose of the promotion of education through the support of interdisciplinary learning and research in the fields of science and religion, conducted where possible in an international and multi-faith context. So that, first of all, it sounds like a wonderful organization and something that I would be personally very interested in. My question for you is, why did you see the need for such a society? And what problem is it meant to address ultimately?
Well, it's needed at two different levels. The one is to try to help put right popular misconceptions. But before you can do that, you must make sure you've got the right theory in mind. So the question is, to what extent does science and religion, to what extent are they in conflict or not? And the basic answer, which most of my colleagues, and it's an interfaith organization, it has people from all different faiths. To what extent is there a conflict? And the initial idea was that evolution would give such a conflict, but basically all serious scientists who have looked at this and who looked at the debate in an open-minded way do not think there's a conflict, because if you, in effect, you're comparing two different ideas. Did God create giraffes and zebras? So, or did God create a system which would produce giraffes and zebras and so on? And if you say, actually, God went the second way, not the first, there's no problem there. Where there, and that does raise various issues, because that is based by the fact that biology will allow that physics will allow biology to exist is a result of the nature of physics. And you can ask yourself, well, why does physics have that nature? That's a foundational question. But the other thing is that there's been a lot of misinformation about this, and there are one or two real issues. And the real issue is, where I think there is a crunch, is, do we have free will? And that has been under attack from neuroscience and various other quarters in recent years, by physicists and so on. And that is something which I and others have been paying a lot of attention to. If we really didn't have free will, if science says you don't have free will, then it would make life very difficult for religion.
Yes.
Of course, as a cosmologist, I'm not in the slightest interested in anything that says the Earth is 6,000 years old or whatever. That's obvious nonsense. And I'm not interested in that debate, because cosmology has gone far beyond that stage. But the issue of the neuroscience and the brain is an interesting one, and it's a deep one. And it's something that I spend quite a bit of time thinking about through my work on the emergence of complexity out of physics.
Okay, so it sounds like your position is that there isn't necessarily so much conflict between theology and science, as long as you frame it in a certain way. And I guess the second path that you outlined of evolution as a system being designed by a transcendent force, and then, freely conducting itself to create all the species. Is that what you personally hold, or are you just putting that out as a possibility?
Being a Quaker, which is what I am, I tend to refrain from theological speculation. And I just briefly want to explain that. Quaker position is that our minds and our scientific apparatus that we design with our minds have only a limited capacity to test what is there, and they can find the regularities explained by science, the laws of physics, and so on, but they cannot find deeper levels of explanation. Science is unable to answer questions like, why does the universe exist? Why do the laws of physics have the nature they do? And so on and so on. And if I believe we have all actually experienced what I call intimations of transcendence. And they depend on our life, what they are. They may be music, they may be awe at the universe, they may be books,
Love.
whatever, they may be your personal life, something like that. And I do believe that those hint at something behind and beyond. But from a scientific viewpoint, the issue is what determined the laws of physics and what made them what they are. And that's a metaphysical issue. And it is as good a understanding of that as any other, that was created by whatever created the universe, whatever you want to call them. But we will be unable to obtain much understanding of that. It's like this image Gamow had many years ago. It's like being confined to the surface of a ball, and whose all experience was on that ball cannot understand what life in 3 dimensions is like. It's simply not possible. And our position would be, my position would be, that the brains we have enabled us to understand certain things, to maybe get hints of what might lie beyond the universe, but certainly we're simply not equipped to, by the very nature of how our brains came into being and how they operate, to discern anything transcendent. We just don't have the capacity.
Do you find that frustrating on a personal level, as either as a Quaker or as a scientist? You know, do you ever feel like, why do I keep researching and I keep coming up against walls and my capacity is so limited? Is that difficult to deal with?
No, I think it's good. I like dealing with it. I like there are different aspects of this. I like my later life has been looking at integrating the different sciences and philosophy, theology, and so on. I'm an integrator. That's what I can do best. And I find it very interesting to see how these things all fit together. And I think you may have seen my book with Nancy Murphy called On the Moral Nature of the Universe, where we try to do that. That was done from a specific Christian perspective, because Nancy is both a very good philosopher and a pastor in a particular church. But you can take what is in that book and remove some of the more Christian parts of it, and I stand by what is in there, and it's very interesting to develop that. So at a personal level, I like to collect what I call the intimations of transcendence, their particular writings, particular music, and so on, and I find that very valuable to have them available to experience them. It's in fact, I'm a mountain climber. I walk on the mountain every weekend, and I find communing with the mountain and nature something which we have such beautiful mountains in South Africa, flowers, animals, and so on. That can be a transcendent experience.
Right, and I could not agree with you more. Of course, there are physicists out there and others who will tell you that's an illusion. You know, nothing special is happening. You know, you could ascribe a meaning to it if you like, but essentially a sunset is nothing but some colors being refracted in the atmosphere as the sun goes below the horizon.
Yeah.
You know, so there is this conflict, and it seems very obvious to me that most people in the world, when they experience a sunset in the right way, feel that something out of the ordinary is taking place, and something that goes beyond mere,
Look, in the end, there's two things. Firstly, the nothing butters, of whom there are a great many, in scientific terms, are often simply wrong, and I could give some examples of that. In experiential terms, all I can say is, well, that's a real shame. You've led such a impoverished life. I'm sorry for you.
Right. Me too.
And you are entitled to say that you haven't experienced it, but you're not entitled to say that I haven't experienced it. You can, if you want to, say that you, George Ellis, have been misinterpreting what you experienced. That's simply your opinion. You're entitled to have your opinion. It's one possible interpretation. But let me take one of the examples where the nothing butters get things a little bit wrong. And let's go back to the free will. And the oldest attack on free will was the theological one. God controls everything, and you have no choice because God is in charge, and there's still people who believe that. The next one was the sociologist who said society controls everything and it's because of your social conditioning. The next lot were the neurologists who said it's your neurons that are making these things happen. Francis Crick was an example of that. The next lot were the psychologists, Benjamin Lieber and so on, saying it's all these patterns, not the neurons themselves, but these patterns in your brain which are doing it. The next lot were the gene people, Richard Dawkins. It's your genes which are doing it. And then I have a lot of physics friends who are very dogmatic. Physics does it all, and everything else above that is mere froth. It means nothing. It's the physics doing it all. So then you say to yourself, my gosh, free will has no chance because there are these multiple reasons it's wrong until you realize they contradict each other. And if one of them is right, the other ones are all wrong. So please choose which of these ones you're going to stick by. And the physicists just laugh at the people who say it's the genes are doing, because the genes are nothing but particles being controlled by the laws of physics. And so it's actually really very funny. The nothing butters about free will are all contradicting themselves, and just as possible as the fact that we have free will. And actually, if you don't have free will, you can't carry out science. The very carrying out of the social subject of the social practice of science depends on me having the free will to cover theory, to propose an experiment, to do the measurements, and then to decide, well, did this experiment support my theory or not? All of that depends on your having a level of free will, otherwise you couldn't do it. And so, in fact, the free will people, the free will deniers, are denying the possibility of science.
That's a pretty strong rejoinder, I would say. And also, I would say, furthermore, they no one behaves, including all the physicists and everybody, like they have no free will. I've yet to come across a person who acts as if they really believe it. Maybe they do deep down, but everyone seems to be involved in some type of moralizing on some level or another and making decisions. But your point is well taken. I want to ask you about, we spoke a little bit about causation, and just to quote you once again, you say, I will claim here that there are indeed other types of causation at work in the real world, described well by Aristotle's 4 types of causes.
Right.
So I found that to be interesting. Aristotle famously had 4 different categories of causation, but 2 of them I would describe as less popular. And that's what's called the formal and the final causes, which seem to smack of purposefulness, a purpose that people seem reluctant to embrace. So why is it that you hold by by Aristotle's view of causation, and you get flack for that in the scientific community?
The scientific community is a broad frame which includes many groups with different views.
Yes.
Firstly, I'm very convinced about this, and in fact, I'm giving talks about this at the present time and about to write a little paper. And I have a very, very fine Aristotle scholar who's going to write this paper with me. And when you say that, so physicists love efficient causation, which is fine, but the physicists like to say that efficient causation only works at the physics level and not at other levels. Well, that's actually wrong. Efficient causation works at all sorts of levels. For instance, it works at the molecular biology level, it works at the physiological level, and so on. But that's one thing. So they agree on efficient causation. material causation is what's the physical causation acting on. And that actually, in the world of biology, that's very different from the world of physics, but we can come back to that. So then you say formal causation smacks of purpose. Well, the first point is that the world is full of purpose, and anybody who denies that is just closing their ideas. They're closing their ideas to the way biology works. But formal causation, this is the effect that the form of things have on outcomes. And the laws of physics by themselves don't tell you a thing. I can write you down Maxwell's equations and neutral equations. So there you are. So what does that tell you? And the answer is it doesn't tell you anything until you tell me what it's acting on in what context. And that's where Aristotle's forms of causation come in. And the formal causation is it depends on the form of what happens. Let me give you a very simple example. If I connect a battery to a light with a switch, then the wires make the electrons flow from the battery through the switch to the light and back again. And it is the form of that circuit which decides what's happened. If you open or close the switch, you change the form of the circuit from an open to a closed circuit that turns the light on and off. That's formal causation. And so in my interpretation, formal causation is how the form of things changes stuff. And in biology, everything is determined by form, the form of the lungs, the form of the heart, the form of biomolecules, and so on. Final causation is the purpose things happen, and biology is absolutely chock-block of it. You have a heart because it pumps blood.
Right,
and
right.
The purpose of the heart is to pump blood. And if you turn the heart off, if you have a heart attack, every single cell in your body dies within a matter of minutes. Now, if you want to deny that the heart has the purpose of pumping blood, you can do so, but it's because you choose, it's because you're a microbiologist, you're only interested in genes and you're not interested in physiology. And science, unfortunately, even biology, is split up into all of these people who are only interested in their own tiny subpart of science. And there's a huge split in biology between the physiologists who look at the big picture and the microbiologists who look only at the small picture. And so my response is very simple. The whole of biology is permeated by purpose. And anybody who denies that just doesn't understand what's going on in biology. I'm just reading this wonderful book by Antonio Damasio called Feeling and Knowing. And he's making this quite clear. The purpose of life, ultimately, the purpose of biological purpose of life is to reproduce and survive. And all of the mechanisms in the body are fine-tuned to help that happen.
Okay, that makes total sense to me. And maybe you could help me understand. Like, I had the pleasure of interviewing Michael Behe a number of months ago, who is obviously a proponent of the intelligent design movement. And what you're saying now and what he says seems to have some overlap. Meaning he was explaining to me about the bacterial flagellum and how that's basically what he calls an outboard motor. It has the exact same structure as an outboard motor on a boat. That's how it moves, and therefore that's what it is. That it has purpose, it has design, in the same way that a heart is clearly a pump. What do you see as the disconnect? What bothers you about intelligent design? And I know it does. And I know it bothers lots of people, but why are these ideas not more in sync?
Well, look, firstly, given the nature of the laws of physics, the laws of thermodynamics, Newton's laws, and so on, if you're going to achieve a certain purpose, there are many ways of doing it, but they will converge to a set of possible solutions. And there's only a possible set of solutions. If you want to fly, you've got to have something like a wing or you're not going to succeed in flying, for example.
Right. Sure.
And so the fact that you see the same mechanism turning up is simply because those are the ways that these happen. And that's the phenomenon of convergence in biology. And that's nothing mysterious about that. It's because biology is constrained by physics. And if you want to swim in water, you've got to have certain features. If you want to fly, you've got to have certain features and so on. What disturbs me about intelligent design is, firstly, I do believe that the laws of physics are fixed and unchanging in the universe as we know them. And anything which denies that offends me as a scientist, because and it offends me as in terms of theology, insofar as I do it, I believe in theology. It offends me as a scientist because those laws are so well established, so well tested, that science is based on their validity, and science tests them, engineering tests them, and there is simply no reason to believe that they would fail in any circumstances. But the question then is, supposing as a theologian say, nevertheless, I'm going to say the laws of physics can be interfered with by God. So then my question is, well, then why don't you then get rid of my toothache? Why doesn't God stop my toothache if he can do that? Why didn't he stop the Holocaust when he could have interfered with these things? If you're going to have this kind of interference, why does God interfere so little? And that's a pretty good question for someone like Behe to answer.
Maybe I'll try to ask him. But I'm not sure that maybe I'm mistaken, but I'm not sure that they believe that a deity interferes with the laws of nature. Maybe I'm wrong, but and I guess I have to look into it more. But it seems to me that that they're positing at the end of the day, the best explanation for the complexity of the natural world is based on a design, a plan. And only recently did they come out and say that, they think that that's actually God. Maybe that's what they thought all along. But before that, they just said a designer. Anyway, it's to me, it's just the reason it's fascinating is because it's an intersection of two of my interests, as I know it is for you, which is how the science world operates and how the metaphysical world operates as well, and what connection they have. And people have been pondering this for thousands of years, and I know we're still working on it. But I just wanted to ask for my own clarification. But let me ask you about non-physical things, which I've heard you talk about in videos and in some of your books. You say it is a big mistake to say that only physical things exist. For instance, an algorithm is an abstract entity, has causal power, but is not physical.
Correct.
Okay. So I have two questions for you based on this. Question one is, what should we learn from that? What should I conclude? So there's non-physical things. What does it mean?
It means that pure physicalism is simply wrong. It is not true that only physical things can have physical effects. And let me give you two other examples, which an algorithm is rather abstract to many people. A nice example is a law. And let's take a traffic law. And there's a traffic law which says if a traffic light is red, you stop, and if it's green, you go. Okay.
Yes.
The law
In
is
America
an abstract thing. So you design a system which makes the traffic light change color, and a motorist drives up and he stops. If it's red, assuming he's obeying the law, he goes if it's green. And that is abstract causation from the law through to the color of the light, through to your mind, which makes the car stop or go. Another one, which is a really interesting one, is the rules of chess. And you've got a chessboard, and the chess pieces only move in certain ways. Now, what is it which is making the rules, the pieces on the chessboard only move in certain ways? And I like to think of this guy from Mars who comes and looks very puzzled. He looks under the board, he can't see anything. He looks at the pieces, he can't see anything.
Right.
It's an abstract rule which has been agreed on over a couple of centuries, which is controlling that. And then, so the physicists say, but it's nothing but it's excitations in a brain. So I say, okay, whose brain? Kasparov's brain. If Kasparov died, do the laws of chess cease to exist? So no. If Kasparov dies, they don't. Okay, so whose brain is it? It's not the same as anybody's brain state, because it's also represented in books. It's written down in books. It's represented in algorithms for chess playing machines. It's written in videos, chess playing videos. And the crucial idea there is multiple realization, that an abstract idea can be realized in multiple forms. The thing itself is not the same as any of those representations. It's not the same as anybody's brain state. It's equal to the ensemble of all of those representations. That's the actual name. in mathematical terms, it's an equivalence class of representations, and that's abstract. So I think it's absolutely clear that abstract entities do have causal powers. You could take an example at the present moment of Putin's view of the history of Ukraine and Russia, which has causal powers. That's an abstract entity, which is causing a huge amount of outcomes. It is realized in his brain, but because he conveys it to other people, it's realized in their brains as well, and it persuades some of his soldiers to do certain things. So there's not the slightest question in my mind. Abstract entities do have causal powers, and the materialist view that only material things have causal powers is quite simply wrong.
Is there any metaphysical overtone to the existence of immaterial objects? Does it mean anything different than, a physicist knows that there are physical objects? Okay, let's say a metaphysicist knows that there are non-physical objects. Does that teach you anything about theology? Does it teach you about anything about a higher power? Or is it just simply a feature of nature?
No, well, from our view, I don't go into theology in that way. It's just a feature of nature. But in fact, the whole of this discussion has gone the other way. The concept of a particle has taken a hit because of quantum field theory. And most quantum field theories, many quantum field theories deny that particles exist.
Right.
And then the string theories say particles are nothing but vibrations in a higher dimensional space. So actually that whole metaphysical story has gone completely the opposite direction. The old idea of particles as billiard balls has gone out the window.
Right. Okay, I have time for one more question. This has been a stellar conversation. You've taught me a lot in a short period of time, so I really appreciate you being here and giving us your time. My question is back to with your science hats. Is there ever going to be a time when we are, so to speak, on top of the pile, where we finally have put together what the nature of reality is like? Or do you think, based on fundamental incompleteness, and chaos that exists in the world, that we will never be able to understand reality for what it truly is? Like, the more close we get to it, the more it recedes from us. Or do you think there will come a time when we'll really be able to piece it together?
I think science, it's like a spreading sphere, that there's a whole massive stuff out there, all sorts of subjects. And we know very well some stuff. We know how light works. We know how Newton's laws of motion works. We know a lot of quantum phenomena, like we know how transistors work. We know a lot about how animals work and so on. There's stuff we know nothing about, and the one which I would particularly put out there is consciousness. We have no idea how consciousness works, and despite what various people may tell you, we don't know how consciousness works. And there's a expanding boundary between what we know and what we don't know, and that boundary is expanding all the time. And will it ever encompass everything? I doubt it. Particularly because we are limited by our machines, our experimental machines. There's a limit to the highest energies we can read. There's a limit to the smallest particle we can see because of the limits to what our machines can do. There's a limit to the part of the universe we can see because of the speed of light. And so there are fundamental limits on what we will ever be able to know.
Okay, so nonetheless, I guess it is your job and others to try, and to get as far as we can, in terms of our understanding. And I for one, thank you for your contributions and your ongoing contributions to the world of science and theology. It's been a great pleasure to speak to you today. And for our audience, please take a moment to subscribe to our channel, like, comment, share, stay on top of everything that we have going on here on AISH and our YouTube channel. Thank you so much for being here.
Thank you very much for hosting me.
Thank you very much.